This is linear, non-linear equations. So this question can come up in your exam, and basically it's your old friend. Use algebra to solve simultaneous equations. 2x plus y equals 5, x squared plus y squared equals 25. So the first thing is here, students don't know where to start, and they start adding 2x and x squared, and they start adding y and y squared and different things like that. They don't know what's going on, but it's not the way to do it. So it actually gives you a hint. I'm going to ignore the hint. We can come back to this at the end if you want. But long story short, I'm going to say to you, before we start, which one is the linear equation and which one is the non-linear equation? You need to identify that. So just spot up here, if it doesn't tell you a power, the power is 1 here, okay? So that is the linear equation. The linear equation, it's linear because both variables x and y are raised to the first power, even though the 1 isn't written there. So, look, in algebra, if you don't see a power on a variable, it is x to the power 1, y to the power 1. The graph, if you were to plot this in a coordinate plane, it would form a perfectly straight line. So hence the name linear. First 4 letters of that is linear. Any equation, so the rule is any equation that can be written in the form ax plus by equals c is linear. So say there again, look at the highest power is 1. Then the non-linear equation, x squared plus y squared equals 25. So how do we identify it? The non-linear one, because at least one variable is raised to a power other than 1. In this case, x and y are both raised to a 2. So the presence of the x squared and the y squares tells you immediately that the relationship between x and y is a constant. And if we graphed it, because the variable is squared, it's some sort of curve, and specifically another part of your course here, this is the equation of a circle where the center is 0, 0 and the radius is 5. It creates a circle there with radius 5. So we're moving on. The rule, if you see powers that like x squared, roots like square root of x are variables multiplied together like x, y, the equation is non-linear. So remember this fella here, this is the tricky one. People think that that's a power 1, that's a power 1, and then that's just a linear one, but it's not. It's non-linear, x, y, and there is a question that come up one year. So here's a summary table. If it looks like this, highest power is 1, it's linear, shape of the graph, straight line, and classification is linear. Again, highest power is 2, it's quadratic, non-linear, and it's a circle in this case, and it's non-linear. Anyway, let's get on to the question. So, where do we start? Start by manipulating the linear equation first. Why do we do this? We do this because you always want to manipulate the linear equation rather than the non-linear one for 2 practical reasons. Firstly, ease of use. Linear equations are much easier to rearrange. You don't have to deal with plus minus signs from square roots or complex radicals, and the coefficient of 1 rule. In your specific equation, y has no number in front of it. Or that means it has a coefficient of 1. This makes it the path of least resistance. So isolate the easiest variable. We want to get one variable all by itself. Looking at 2x plus y equals 5, it is much easier to isolate y because it doesn't have a multiplier. Basically, it has 1 in front of it. So subtract 2x from both sides, and you get left with y is equal to 5 minus 2x. So there's the first manipulation. Now you have a translation for y. You have something that you can substitute in instead of y. Everywhere we see y, in the other equation we can write 5 minus 2x instead. So the substitution of the bridge here, take the non-linear equation and plug in your translation. Here's the non-linear equation. Plug in the 5 minus 2x instead of y. Simple as that. That is the swap. Then you go, and now the equation only has x in it. You've successfully removed the y obstacle code. Right, so let's follow the steps here to break it down, and we'll see you in the next video to do that.